The overall goal of this procedure is to demonstrate the design and operation of a 3D printed microfluidic crossflow cell for the purpose of testing the performance and fouling propensity of polymer membranes.
This method can help researchers in the membrane field to study membrane performance and fouling propensity using microfluidics at elevated pressures and well-defined flow conditions, with minimal costs. Advantages of this small-scale setup includes the ability to perform separations of small amounts of high-volume materials, to perform membrane studies requiring expensive reagents and materials, and to test multiple new membrane formulations or modifications in parallel.
Begin by designing the microfluidic device in 2 separate parts using a computer-aided drafting program. To make the bottom layer, use the rectangle tool to draw a 40 mm by 60 mm rectangle. At one corner of the rectangle, use the circle tool to create a 6.2 mm diameter circle. Center this circle 10 mm from the left edge and 10 mm from the bottom edge. Then, use the linear pattern tool to replicate the holes across the rectangle with 20 mm spacing for a total of 6 holes. Next, use the fillet tool to fillet the rectangles with a radius of 1 mm. Then extrude the part 10 mm using the extrude tool.